So, hi all, my name is Andrej and I want to show you how I build and how I operate my personal AI bug bounty and bug hunting harness. And before we dive deep, let's start with a little bit of background. So it started as a funny little side project, as most things do, right? And I, of course, want to stay in touch with the latest developments in AI. I mean, all of you must have heard about all the proceedings that are happening in AI on a daily basis, and I don't want to stay behind. So I thought that, why not find some cool idea for it? And bug bounty and vulnerability research always appeared cool to me, like coming to these OWASP meetups and hearing from Kamil and others about cool vulnerabilities they found. It was really inspiring to me, but I never really took serious action, like to delve deep into that. So I thought it would be nice to combine, right? Vulnerability research and AI, and I will fix that in a second. Sorry for that. Windows being Windows. Funny enough, it is set to 1 hour timeout, so I don't really know what's going on. Maybe you have a hint on what might be causing the issue? Okay, back to action. Hope it works now. Would be nice to combine AI, vulnerability research, and to maybe learn what is the magic behind those cyber weapons released by all those companies, Xbow, Bug Bunny AI, and also providers like Anthropic with their Mythos and other, famous cyber weapons. And then it's off again. Možno to môžem, Kamil, hodiť tebe na noťaz? Keď to viem nejak rýchlo šernúť, lebo neviem, čo má. Kam ti to môžem nazdieľať? Signál? Jo, PDF-ko. Tak mail? Jo, mám data. Jo, jak máš adresu? Tak to jo. Jo.
Sorry everyone, we will switch the laptop.
Máš Firefox?
No.
No. prosím ťa, ešte asi display. Yeah, okay, we're back. Sorry for the technical issues, but let us continue. So, you heard the motivation. And because now I'm using AI, I consider myself a vulnerability researcher, right? Now that's a joke, and I would like to give kudos to everyone who is doing like a true vulnerability research. This is all like role plays during the evenings. But even so, it managed to find some, I think, interesting vulnerabilities already. So yeah, you'll see in a moment. And since I have a full-time job to do and I want to have a life outside of AI, outside of cybersecurity, and outside of computers, I set some criteria that it must follow for me to be usable. And the first one is obviously I want it to be autonomous. I want it to be a cyber weapon that won't require any or minimum human interventions. And my typical workflow for this is to wake up, launch some reviews using this tool, then do my actual work, have a lunch break, give it 2 or 3 prompts, ask questions, steer it a little, and then again let it run, do my actual job, and in the evening have reportable findings from this that I can submit to maintainers as advisories. And regarding the ratio of false positives and false negatives, I heavily value having no false positives in a sense that I don't mind missing stuff, but I really don't want to waste my time on triaging bullshit stuff. So if I miss something that I might have caught, I don't really mind. I just want to go on. About OPSEC, yeah, OPSEC in AI is hard. You cannot really avoid prompt injections. And if you can, I want you to show me how. There are some other measures you can take. But what I did, I just built or took a separate computer, on it build a separate VM, and I only review trusted targets. I only do white box source code reviews, and I don't do any interactions with live targets. So that's what I consider is good enough OPSEC for me. And I have a huge preference on having the quality out of it. So it needs to find vulnerabilities, it needs to prepare reports, validate them, and I only want to copy and paste them, and I want to take profits, right? You will see that it is not that far yet, but these are all ideals, right? So here are the promised results. Yeah, the number one that I'm most proud of is Vim, and I hope you all use Vim. But anyways, apart from valid vulnerabilities and those still in queue, there were like tons of duplicates. And you can imagine that more people had similar motivations as I did. So, and with the state of current bounty and how the maintainers are overwhelmed, you can easily find yourself waiting for months in triage. So it's like, I can maybe share updated results in a few months' time, and we shall see how it performs in the meantime. Let's go into the architecture and into some key features the review pipeline and the tool provides. So as with most AI stuff, it's really just a bunch of markdown files, and it probably will be for some upcoming time in all those fancy AI tools. But really, it's a harness built on top of Cloud Code that most of you, I guess, already used for some coding or scripting or doing little tweaks. Yeah, it's also useful for doing reviews of code bases for security. So it's a set of commands, skills, and to that there are a bunch of what I consider high-quality resources for it to follow, like methodologies and write-ups of like older vulnerabilities that get published either from bug bounty programs or from open source repositories as GitHub advisories, etc., etc. And to that, there are a bunch of deterministic tools and scripts for both helping the vulnerability discovery, so all good AppSec tools for static analysis, dynamic analysis, fuzzing, etc., etc., but also for making the AI models behave the way you want them to behave. Because I'm sure that plenty of you face a situation where you tell the model to do a thing, you wait for half an hour, and it tells you, oh, anyways, I did partially what you wanted, but I also did this many of other stuff. So yeah, I'm trying to battle that using deterministic tools and gates for it to follow. And I keep repeating this AI harness or scaffolding stuff. So I tried Googling for it to show you what you can consider a harness. Well, better take a look at the right side of the screen, and especially this middle box, because that's pretty much what the harness is. You have some foundational model, which would be Opus or Codex or GPT 5.5, or those open source or open weight Chinese models. And on top of that, you have the harness, and that is how you manage the context, how you provide or don't provide memory to the model, how you give access to use tools, to verify the results, etc., etc., etc. So all of that is considered a harness or scaffolding. And the typical workflow, how to use this tool for a given repository that you want to review for vulnerabilities, would be to open it in Claude Code, the editor used to do agentic software development. Then you run the /review command. Then you pretty much wait for 2 hours, give or take. And once that is done, you review the results, you ask follow-up questions, you demand better coverage, you steer it if you want to, etc., etc. And once you are happy, you let it generate the report, run quality assurance phase, and then you can submit the report. And then you can wait half a year for triage from the maintainers. But I don't blame them. It's like a hard situation for them. So I guess they'll need to adapt some kind of similar workflows of their own to catch up. But anyways, you saw the wait for 2 hours. And during those 2 hours, the whole autonomous pipeline takes place. And you can see it's divided into multiple phases and multiple stages. And don't worry, we'll go through an example for those. But just to give you a brief idea and overview. So as usual with pentest, we get some reconnaissance. Then we do some scanning for vulnerabilities. We verify the vulnerabilities, try to construct POC, report it, etc., etc., etc. Maybe the most important or interesting bits are that during the scope phase, it will choose a subsystem to review in the given run. Because imagine that you have a code base of 2 million lines of code. You can't expect a model or a tool to review it all in a single run. So what it does, it like extracts the subsystems from the repository, then reviews them one by one. During the threat modeling, it tries to define what is a vulnerability, what are like the diamonds or the most important bits inside the given application, who is a potential attacker, what he might or might not possess at the start, etc., etc., etc. And the outputs from the reconnaissance phase are used throughout the rest of the review. Then we have scanning, and it starts with, let's say, 3 types of scans. First one would be a classic static analysis using SameGrep or other tools if you wanted to. But it also does, I call it a manual scan, in which it tries to like go over the code base or the scope systematically and hunt for or find potential vulnerabilities. And as you can imagine, that is by no means thorough. So for that, I have the broad phase or the broad scan, which uses a cheap model, Haiku from Anthropic, and it runs on every single file in that scope that was chosen. And this is to ensure coverage. But you might be wondering, okay, but who writes the prompts for the Haiku? Or what does the prompt look like? And the catch is that the prompt is generated by, let's say, the thinking, the most capable model, Opus. So Opus, based on reconnaissance, generates prompts that might be relevant for the given code base, and then uses the cheap model to run throughout the code base and to find potential candidates for vulnerabilities. And yeah, so that was the scan. Then we have some, as I was mentioning, deterministic scripts to enforce coverage and to let it rerun if it missed something, if it doesn't match what was expected. And then during the fourth phase, it does two things. Again, uses Opus, the most capable model, to generate custom semgrep rules, which are rules used for static analysis approach. And again, it takes information from the reconnaissance, like what are the relevant technical approaches to, I don't know, authorization. Does it use decorators or does it use, I don't know. And then based on that, it generates rules for static analysis, which again runs on the whole code base to have coverage for that. And this scanning phase or stage gives us candidates that were not fully evaluated yet. They were not POC'd, but they might be a real vulnerability. So we move to the hunting phase, which again, the most capable model generates like a plan. Okay, I have these 50 potential candidates from the previous phase. So I need to decide how to cluster them so that I can proceed and deep dive into those. So in the plan, it is clustered and divided. And then there is this hunt fan out, which like let's run 4 to 6 to 8 sub-agents and to go deep into those potential clusters. So one might be focused on authorization issues. The other one would be on injections to the outputs or whatever. And once this is done, everything is merged so that we can proceed to validation. Because as you probably know, models like to hallucinate, and even if you tell them not to hallucinate, they somehow do. So we need to like keep telling them that, okay, but really behave. And that is done in this validation and POC stage. So the validation, it gets a limited context. It doesn't see the thorough output from the previous phases. It only sees that, okay, there might be injection in this based on, I don't know, missing sanitization of inputs. But it is not given the rest of the context. So it has to like verify that, oh, this really might be an injection. And you wouldn't trust how many findings are eliminated at this phase, just based on hallucination from the previous phases. And yeah, once we have like, these are really good candidates for vulnerabilities, it tries to build a POC, like locally, to bring up the repository, the application in Docker container, and to try to construct a POC to prove the vulnerability. And once it has that, it goes through the rest, which consists of trying to chain and to maximize the impact. So for example, if you have IDOR where you can read some object you are not supposed to, maybe you can also write to it, right? Makes sense. If you have two vulnerabilities, maybe you can combine them for better impact. And this is all done in this stage. Oh yeah, and the deep dive, there's a rule that if there are none high or critical vulnerabilities, it needs to re-evaluate again and go through the missed stages or missed candidates. Because even if you tell it like multiple times to be really thorough and to have good coverage and everything, if you ask it here, hey, what are the areas that you have missed where we can take a further look, it will straight away tell you 10 more potential candidates it didn't go through in detail. So this is attempted here. And once we have that, we go to reporting, and then I take over as a human. So this all runs autonomously during my actual work or job. And just to give an idea about the structure, so as I was saying, it's just commands, templates for agents, skills, scripts, pretty much standard AI harness you would find nowadays. And how to use it and how to install it is that you would download this, you would run install, it would create symlinks for you, and then once you open Cloud Code or Codex or whatever AI editor you want, it will be available as commands, skills, and those other terms in those AI coding editors. And some key features that I want to highlight are the following. So as I mentioned, it's multimodal. So it uses chip model when it's appropriate, and it uses the most capable and the most expensive where it's appropriate. It uses a pattern of orchestrator and subagents, and even nested subagents to manage context and not to overflow context window. Yeah, I was already mentioning the deterministic scripts. I try to give it the most high quality resources as references as I could. And yeah, the POC. And one, I believe, really nice feature is it has two review modes. The first one is like full review. Hey, go and review this code base. And the second one that might be relevant to the AppSec teams is to run only change reviews. So imagine that you have a code base that you take care of as an AppSec person, and you want to like repeatedly review it, right? But if you have 2 million lines of code, it's not feasible to run the review every single week because we'll get to the cost of it. So what you can do, you can run just the change review, and you can like pin it to a specific version or date or commit or whatever to have ability to run like incremental reviews. And right after this, we will deep dive into a case study and like end-to-end example. But if you guys have any questions, please let me know right now. Yeah, I think. Really, it was incremental. Like the first attempts were that I opened a code base and I prompted like, hey, go find vulnerabilities. And it gave some results, which were not that good. So then I observed that, okay, if I tell it to like follow the reconnaissance, the scanning, and then the validation pattern, then it can give better results because that's what we do during pen tests, right? So it did, but then I found myself like repeatedly running the same prompts and commands over and over. So I thought, okay, it needs to run this autonomously. I always want it to double check the finding, so I don't want to prompt it myself anymore, right? It needs to do it on its own. And then, of course, I will have the acknowledgements at the end, but this is not a unique tool. There are plenty of tools like this. So I, of course, took inspiration, but then brought some ideas of my own, and also providers like Anthropic, OpenAI, etc. They give like really good resources on how to build the harnesses for AI if you want them to run like multi-hour workflows. So yeah, really a combination of of inspiration and then some what I consider original ideas of my own. Any other questions? Not really. They offer opportunity to like register yourself as a researcher, and if you give like references to already published vulnerabilities you found, they will like provide you access to it in unrestricted manner or somehow less restricted. Yeah, but even that didn't give me access to Fable. Like with Fable, this was failing instantly because, yeah, a pity.
Question regarding the closed code. I'm not familiar with that. Did you architect the agentic flow, or is it built in? So you didn't have to deal with inferences directly? Like you didn't have to construct all the agentic framework that you can do?
Yes, it provides it for you. It was not as developed as it is now. I started with this in late February or March, and now it, like, for example, back then it didn't support the nested subagents, so you had to work around that. Now it supports. And thanks to how capable and how well they train the models on using the code itself, you don't even need to understand how to use the Claude code. You can just ask it, hey, I want to run like 5 commands in chain, like propose an architecture for me. And it will bring something similar to this.
Are you using some kind of LLM memory for like orchestration?
No, I wanted to avoid like biases between the runs. I have an experimental feature there that once the finding is like at the end of the review and I'm submitting it to bug bounty or to maintainers, it asks me that, hey, I auto-extracted this pattern. So for example, I observed that if we have this technology and this endpoint, then it can lead to this finding. Do you want me to note it down? And it can. And then during like further reviews, it will reference that file and try to check for it again. But it introduces bias into the review, and then you find, if you find, for example, denial of service vulnerability in a specific manner, then it will try to find that in all subsequent reviews. So you have to be careful about like introducing that.
I have a question regarding validation process.
Mm-hmm.
And whether it's like fully done by LLM to be as a judge, or like you have some deterministic way, like for example, LLM generates like Python script or like full command or something like that. You will have some kind of deterministic engine which will try to execute that to check like some output or something like that. Because like we are using similar like tool, not based on Claude Code, but it's like something like agentic loop and so on.
Mm-hmm.
And we have kind of issues with this validation because it's surprisingly hard to validate findings. So like, can you maybe share a bit info about this step, like how this works for you?
Mm-hmm. Yeah, so out from this phase, from this merge, there's a structured JSON or whatever it has to follow to describe a finding. So it has to give like a specific references to lines of code. It has to give specific references on how the vulnerability would theoretically work. So that serves as an input for the validation in here, but it's all like LLM based. And for the practical validation is the POC in Docker. So it needs to like construct, execute, and observe a valid POC to be considered a finding. If I were in an AppSec team for like a specific code base, I believe in that sense it would be viable to try to build and harness specific for the code base. but I want to be like code base agnostic. I want this to run on MongoDB and then the other day on Keycloak, so I can't really abstract like that level. So that's why I'm mostly LLM based. But yeah, it's not perfect by any means. And then after the reporting phase, I'm doing the prompts during my lunch break, and I often find it like, okay, buddy, this is not really a vulnerability, but a feature, because it's hard to tell somehow, and sometimes. Yeah. Anyways, yeah. Yes. Yeah. There are like prompts instructing it to, okay, take a look if there's a Docker compose or a Docker file for the repository. If yes, we won already because you can spawn and run it. If there is not, go check if they mention in documentation how to install or how to run this application that we are reviewing. Yeah, well, maybe I'm biased in what types of repositories I review using this, but I would say it's fairly capable of like running what you want it to run. Like most of the repositories that I reviewed, it was enough to do the prompt to, hey, build this up in Docker container and then like build step-by-step end-to-end POC. Including like if you have to, for example, bootstrap an administrator account and use that to create user accounts, it's all capable of that. But that's like not my magic, not something I created. It's just the state-of-the-art models that are that capable, I believe. Okay, let me go through a case study for one particular vulnerability it discovered, and from like end to end, from the beginning until the end of the pipeline. So just to give you context, it was found on GoBox Pro, which is a web application that is used to like manage messages with government in Slovakia. It's provided by Slovensko Digital. It's a non-profit organization that like tries to provide better digital services than the state does. And this is like their product, SaaS application that you can like sign up to, pay them a little fee, and have this nice interface to communicate with the state. You can imagine this as datová schránka in Czech Republic. It's similar but provided by non-profit. And so I thought, I read the blog post about some Slovak researcher like finding vulnerabilities in their repositories and like trying to help them like improve security. And so I thought it would be nice to try my approach. And after I ran it, it managed to find a critical vulnerability, for high severity vulnerabilities, and a couple of mediums and lows. And yeah, kudos to those guys for how they responded to the adversaries. It was like I pinged them on Slack on 10 in the morning, and by noon it was all fixed and deployed in production. So really, maybe they got scared a bit, but really kudos to them for how they responded. And one of the vulnerabilities was this escalation from tenant admin to like site-wide administrator using a duplicate mail. And the scenario for this, if you wanted to execute it, is to be a tenant admin. It might seem overly privileged, but it's not. If you are a customer of theirs, you are a tenant admin in your own tenant. And what you need is to guess or to brute force an email for the site admin, but it's really easy because there are like 4 people working in that nonprofit, so you can take an educated guess. And then what you can do, based on lack of controls, you can change your email to that email, and voila, you have access to Good Job Console, which is a tool for Ruby on Rails applications to like manage pipelines and jobs that you would need to run in your application. And once you have that, you can like manipulate the job, for example, the syncs to the government API, the notifications, etc., etc., etc. And if you wanted to access like message contacts with the government, you could use one of the other vulnerabilities that were found, not this particular. Anyway, so here's the root case, and this is not yet output from the pipeline. This is just to give you an idea. So yeah, the check for the site admin was made by this. So if you have a proper email, you are like an administrator. No, it's not part of the session. It's just each time you try to access this restricted workspace, it gets fetched from the database and compared. And email address is only unique per tenant, not per deployment. And you, as a tenant admin, can set any user's email, including your own, right? And you probably see where this is going already. But let's see how the LLM handled this and how it's like escalated. So from the reconnaissance, and just to give you an idea, there are like, let's say, tens of files that are produced as a result from the review. So every single phase that you saw like produces and outputs to a file. And I'm just seeing like snippets of those key and relevant to keep it short. So from the reconnaissance phase, it noted down that the email is like the protection mechanism for the Good Job console. So it is like, okay, if we somehow can manipulate the email, we can maybe access the restricted functionality. Then from the threat model, it noticed that, yeah, there are indeed 49 like endpoints. It does this and that functionality, the Good Job API, and it is like site admin only. So that is potential like diamond for us to pursue and to try to get to. And then in some other file, it produced that, hey, phase 5, go check that the gate leading to this functionality is robust and that does not provide like tenant crossing somehow. So it like already gives ideas to the latter phases to, hey, you might want to check this out. This is really, really interesting. Now to give you an idea of the broad scan run on every single file. Unfortunately, this vulnerability was not discovered during that phase. So I'm showing the outputs of the other vulnerabilities of IDORs and mass assignments. But it's really like a testify that even though if the static analysis tools and the broad scanning miss it somehow, it's still cached by the other phases. So here you can see first one for the IDOR. So you can see that in this line, for this particular Ruby file, there is no verification of tenant. So yeah, you can, once you are tenant admin, you can access resources from other tenants because there's only a check if you are admin. And also this one mass assignment, and it like permits you to assign a tenant admin to objects from or tenant IDs from objects from other tenants. So you can come to configuration of some other tenant, some other user, and you can tell it, okay, now you are my tenant, so I can read you and I can use you. And this way you can access the configuration that contains the API credentials, etc., etc., etc. And this was all done, by the way, by the cheapest, by the like most trivial model from Anthropic, the Haiku, that is used for broad scanning of every single file based on prompts from Opus. So like no human interaction in that. And again, on example of the IDOR, the custom rule for the static analysis for SemGrep. Again, generated by Opus, and this rule using static analysis tools is applied on every single file. And so in case we have this pattern, and at the same time, like there's no check for tenant, for group, for some Ruby authorization mechanisms, it is flagged as a potential finding. And now let's get back to the email vulnerability. And yeah, you can see in the hunt phase, so this is the one that goes really, really deep and tries to like reference particular lines and files and everything. It says that the site admin is derived from this config option, and it's matched against the same email the attacker might be able to forge. And for now, it was thinking about forging it via OAuth email, which is not that practical. But we have the other phase for hunt, and that is like hunting for variants. So if it has like, okay, I might be able to get to that email by spoofing OAuth, which is not that practical, I can look for variants, maybe I can access it in some other manner. And it really, really did, because it found that the email uniqueness is only tenant scoped, not global, and that the tenant admin can set any user email, including their own. And on top of that, there was like no binding to the session and no session invalidation. So once you change your email and then you query the admin endpoint, it is fetched from the database, compared to your email, and voila, you are a site admin. So now goes the validation phase, and here it gave verdict, okay, this is confirmed, because you can get the identity provider spoof, or anyone who can like somehow attempt to match the email in a cross-tenant manner, as was shown in the previous output. So right now it thinks, okay, this is really a valid finding, let's go for POC. And here we have demo output from the POC. So on the first one, it confirmed that, okay, I can indeed set an email to already existing email. So we have two admin@test.com, one and the second one. And in the latter example, it goes like full end-to-end, and it first logs in, tries to access the admin endpoint, gets 404, then changes its own email, tries to access again, and gets redirect to the endpoints. So it proven to itself that, okay, this is truly reproducible, and I can consider this as a valid finding, and I can present this to Andrej once he's on his lunch break. And after that, it generates a report. This is just a header, and then a full body of all the details that we went through would be presented there, including like a copy and paste POC. So you as a maintainer or bug bounty triager, you can like briefly see if this is valid or not, and try to replicate on your own. And yeah, now for some closing remarks, but maybe again a place for questions related to the example, and now we'll get some, well, let's say lessons learned from all this.
I'm not sure if I missed it or not, but what's the average price for that per one vulnerable
Yeah, I don't have like per vulnerability. And you mean like cost of running this, or like based on the estimates, is like equivalent to $100 in API tokens, but it's way cheaper if you use the subscription. We'll get to this in a moment. Don't worry.
First question, I thought we will get to it during the demo, but I didn't see that. When you then you tell it to like go through this repository and do your stuff. Have you run your humps? Or?
Yeah, pretty much, yeah. You just run /review and it does all of that. Because the installation, everything is done when you download the repository and you run install, it creates the same links to your like home Claude, so that it's once you start Claude code in every or any directory, it's loaded for you to run. Okay, so some future work. Of course, this needs like heavy improvements. I definitely need to improve the technical quality of it and all the scripts, prompts, skills, commands. It was mostly vibe coding, as I don't have that much time to invest into this. And when I'm playing with it, I want to have the fun parts, you know, finding and validating the vulnerabilities, not the boring stuff, the reviewing of markdown files. So yeah, I would definitely need to get better in that. And of course, in completeness and in coverage, despite of all that I said about the checks and the gaze and everything, it's still not thorough. But it doesn't mind that much because the current goal is to discover vulnerability, not to do thorough pen test. But if I wanted this to do a thorough pen test, I would need to improve on the coverage. And would be great to add some vulnerability class specific instructions, resources, and novel approaches. So this is like a call for action for those true security researchers that have like some truly unique approach to finding stuff. Go and combine that with something like this, and you might get great results. I'm stuck to just like the publicly known and basic stuff, so yeah. And eventually I want to and will need to add support for other providers and like figure out how to use this with local models because it's cheap, relatively cheap now, but it won't be forever, as we'll see in a moment. Do you have a question?
Did you test or train it on someone where the vulnerabilities are known? Like, I don't know, GitHub issues closed or only 10 vulnerable web apps?
We'll get to that right here. Yeah, so for the lessons learned, and first on LLMs used for finding vulnerabilities, my mantra in this is that being different is more important right now than being better than other tools. So you can find like 20 such tools on the GitHub that are like regularly run on the bug bounty programs, but I can still find unique vulnerabilities and vice versa. And it's not because I'm better, but because I'm doing it a bit differently. And you know, with AI, it really matters how you phrase the prompt. So yeah, and what I found is really good approach is to let it run and try to find variants on existing stuff, meaning on existing vulnerabilities. So during the early stages, the reconnaissance, the recent or sometimes all findings for the given repository are fetched, and then later on are referenced and checked for like incomplete fixes. And you would be surprised how often it happens that maintainers are like provided with really serious vulnerability on one endpoint, but leave the exact same vulnerability open on the other endpoint. So really pays off to like hunt for variants. And it's not that great in being creative as of now, might improve. And yeah, the always coming intended feature versus vulnerability problem. Even though I have multiple prompts for it, I still occasionally need to tell it, hey, dumbass, this is like intended, it's a documented feature, like it's not a vulnerability that admin can, I don't know, create users or whatever. So yeah, and now for the like damn vulnerable web applications, I think that the best is to work with real data and real targets as soon as possible, because in those public, intentionally vulnerable apps, those can be in the training data for the models, so it will be skewed. And if you create your own intentionally vulnerable application and try to like train and improve on that, you will get a different ratio of false positives versus false negatives. Because in your intentionally vulnerable project, there will be a different distribution of vulnerable versus non-vulnerable code. So I advise to go for like real targets to get real results. And yeah, the meme is true. Unfortunately, I cannot ask properly, so I'm stuck in the middle, like building all the fancy harnesses and everything. If you want to meet the guy on this edge, go check out and go talk to Maciej Smička. He published some really nice stuff on how he approaches finding vulnerabilities AI and how he like discovered vulnerabilities in Firefox, Chrome, etc., etc., etc. So much cooler targets than what I have showed you. And now for the harness design, you don't need to go for long chain or other like fancy tools to build an agentic workflow. Claude Code and Codex are both more than capable of doing so, in my opinion. And they will also like hint you how to proceed. And they will also let you use the subscription as compared to the API tokens, which will pay you off, as will be shown later. And yeah, what I like to do, as you've seen, combining with deterministic tools to enforce completeness, already talked about that. And nice approach, I think, is this meta-harness development. And you pretty much open Claude Code and tell it, okay, based on this really good reference for Anthropic and the previous logs from previous sessions, go and review those logs and propose improvements to match the best practice recommendations. And it will give like multiple points that, hey, you are not using this skill efficiently because you overrun the context window or whatever. So yeah, and in future with better models, we will be able to get better harnesses this way, etc., etc., etc. So the room for like truly human addition to this will like diminish and diminish, I think. And yeah, obviously very key to manage the context window. So that's why I use those agents and sub-agents. And really pays off to like reprompt multiple times. I have this example with the quality assurance agents. So it pretty much tells it, okay, go through these reports line by line. You are bug bounty triager. You want to identify any mistakes. You want to spot if the POC doesn't execute, etc., etc., etc. And you let it run 2 or 3 times. And at the end, you can be pretty confident with an asterisk that you can copy and paste the report to bug bounty platform and it will be accepted. With an asterisk, of course. You still need to like think. But yeah. And now on the operations, as promised, the model providers, even though that I like made advertisements for Anthropic stuff, they are not your friends. Like 2 weeks ago, it happened that on random Thursday morning, I started the tool, and out of nowhere, stopped doing the reviews. It told me that, hey, you are not authorized to run security stuff using Claude subscription, blah, 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 blah. I was like, oh, well, damn, I'm finished. It got better in the afternoon, so I could proceed. But yeah, you all remember what happened with Fable, and imagine being like business dependent on it. So I think it's, you either need to have like direct cross-provider support and then support local models, or you need to be ready to like switch really fast if needed. So if random Thursday morning comes, you need to switch, and you are running on Codex in 2 hours. That's what I would try to achieve. And yeah, now we have the era of cheap access to great quality models, but it cannot last. It simply cannot due to valuations and the upcoming IPOs, etc., etc., etc. It won't last. For example, in one of the previous weeks, when they introduce the Fable, once they introduce a new model, they reset your like subscription spend, so you get more tokens to spend. And in that particular week, I was able to run 25 reviews. And based on the estimates from the cloud itself, if it counts the API tokens, it gets up to approximately $100 per review. So like multiply that by 25 by 4 weeks, and you get that much value sometimes for not even 200 euros per month. So this won't last, so let's enjoy cheap models while we have them. And finally, my take on the future of all this. And this is really like personal opinion. Don't take it as it will happen. It's just what I think. In the truly like long run, I think that, and it applies even now, that better the model, the more mistakes you can make, and it will make up for you. So eventually, I think that model providers will be the true winners of this, and they will have all this stuff built in their harness. To some extent, they do even now, but they don't want to burn your subscription that fast, so they are not as thorough, but eventually they will be. And I think that the projects will be checked automatically for like 99% of vulnerabilities for OWASP testing guide coverage, et cetera, et cetera, et cetera. And the truly novel research I think will be done by humans using AI, and until the LLMs can be really creative, and then we are all doomed, I guess. But in the meantime, I think it's a great opportunity to play with it and to like complement traditional AppSec services and pen testing as a service. And yeah, the AI is overhyped, but it like truly provides new capabilities. I mean, I was not able to do this stuff while working full time. Now I am, so for me, it's a proof that yeah, it is a new capability brought by AI. And I think there's still edge to be gained with a good or a different harness, and of course the cheap tokens. And finally, I would like to acknowledge all the other similar open source projects like this. This is not unique, it's just a bit different. And then, of course, I took as inspiration and as resources like various bug bounty and pen testing stuff. And of course, guides from Anthropic, OpenAI. And I would like to highlight Ale, I don't know how they are pronounced, but they are guys building a similar thing using mostly local or open models. And they are based in Prague, so go check out their resources. I think it's really, really cool that we have such company in Europe, and even more in Czech Republic. And yeah, if you have any questions or remarks, I will be happy to answer.